Good day everyone, my name is Mildred Lafuente and today I'm going to present my course project in Data Communications Networking 4. The topic that I choose is the Group 1, which is point-to-point connection, branch connection, and access control list. So here in point-to-point connection, one of the most common types of WAN connections, especially in long-distance communication, is a point-to-point connection, also called a serial list or line connection. So here, we have the serial point-to-point overview. The common type of WAN connection is the point-to-point connection. As shown in this figure, a point-to-point connection are used to connect LANs to service provider WANs and to connect LAN segments within an enterprise network. A LAN to WAN point-to-point connection is also referred to as a serial connection or leased line connection. This is because the lines are leased from a carrier and are dedicated for use by the company leasing the lines. So next, we have the point-to-point communication link. When permanent dedicated connections are required, a point-to-point link is used to provide a single, pre-established WAN communications path. This path goes from the customer premises to the provider network and to a remote destination, as shown in this figure. Next, we have the serial bandwidth. Bandwidth refers to the rate at which data is transferred over the communication link. The underlying carrier technology will dictate how much bandwidth is available. And next, we have the WAN encapsulation protocol. So on each WAN connection, data is encapsulated into frames before crossing the WAN link. To ensure that the correct protocol is used, the appropriate layer 2 encapsulation type must be configured. The choice of protocol depends on the WAN technology and communicating equipment. The following are short description of each protocols. HDLC, the default encapsulation type on point-to-point connections. Dedicated links and circuit switch connections when the link uses two Cisco devices. Next is the PPP, provides router-to-router and host-to-network connections over synchronous and asynchronous circuits. Serial Line Internet Protocol or the SLIP, a standard protocol for point-to-point serial connection using TCP or IP. The X.25/link access procedure balance, an ITU-P standard that defines how connections between a DTE and DCE are maintained for remote terminal access and computer communications in public data networks. Next is the Frame Relay, an industry standard switch data link layer protocol that handles multiple virtual circuits. Next, we have the HDLC encapsulation. HDLC is a bit-oriented synchronous data link layer protocol developed by the International Organization for Standardization, the ISO. The current standard for HDLC is ISO 13239. HDLC was developed from the Synchronous Data Link Control standard proposed in the 1970s. HDLC provides both connection-oriented and connection-less service. HDLC uses synchronous serial transmission to provide error-free communication between 2 points. HDLC uses synchronous serial transmission to provide error-free communication between 2 points. HDLC defines a layer 2 framing structure that allows for flow control and error control through the use of acknowledgement. Each frame has the same format, whether it's a data frame or a control frame. Next is the introducing PPP. PPP encapsulation has been carefully designed to retain compatibility with most commonly used supporting hardware. PPP encapsulates data frames for transmission over layer 2 physical links. PPP establishes a direct connection using serial cables, phone lines, trunk lines, cellular telephone, specialized radio links, or fiber optics links. Next, we have the advantages of PPP. PPP originally emerged as an encapsulation protocol for transporting IPv4 traffic over point-to-point links. PPP provides a standard method for transporting multi-protocol packets over point-to-point links. There are many advantages to using PPP, including the fact that it's not proprietary. PPP includes many features not available in HDLC. The Link Quality Management feature, or the LQM, monitors the quality of the link. LQM can be configured with the interface command ppppp quality percentage. If the error percentage falls below the configured threshold, the link is taken down and packets are rerouted or dropped. PPP supports POP and the CHOP authentication. So here we have the PPP layered architecture physical. A layered architecture model, design or blueprint that aids communication between interconnecting layers. The figure maps layered architecture of PPP against the Open System Interconnection or the OSI model. PPP and OSI share the same physical layer, but PPP distributes the functions of LCP and NCP differently. At the physical layer, you can configure PPP on a range of interfaces. The only absolute requirement imposed by PPP is a full duplex circuit, either dedicated or switch, that can operate in an asynchronous or synchronous bit serial mode. The physical layer standards are transparent to PPP link layer frames. PPP does not impose any restriction regarding transmission rate. So next we have the PPP Link Control Protocol. Here in Link Control Protocol functions within the data link layer, it has a role in establishing, configuring, and testing the data link connections. So here LCP function within the data link layer establish the point-to-point link. LCP also negotiate and set up control options on the one data link, which are handled by the NCP. After the link is established, PPP also uses LCP to agree automatically on encapsulation formats such as authentication, compression, and error detection. Next, we have the PPP Network Control Protocol. PPP permits multiple network layer protocols to operate on the same communication links. For every network layer protocol used, PPP uses a separate NCP. So here, NCP includes functional fields containing standardized codes to indicate the network layer protocol that PPP encapsulates. Next, we have the PPP frame structure. A PPP frame consists of 6 fields. Here are the following: the flag, a single byte that indicates the beginning or end of a frame. The flag field consists of the binary sequence 01111110. Address, a single byte that contains the binary sequence 1111111, the standard broadcast address. PPP does not assign individual station addresses. Next is the control, a single byte that contains the binary sequence 0000011, which calls for transmission of user data in an unsequenced frame. Protocol, 2 bytes that identify the protocol encapsulated in the information field of the frame. The 2-byte protocol field identifies the protocol of the PPP payload. Next is the data, 0 or more bytes that contain the datagram of the protocol specified in the protocol field. And last one is the frame check sequence, or the FCS. This is normally 16 bits. If the receiver's calculation of the normally 16 bits. If the receiver's calculation of the FCS does not match, the FCS in the PPP frame is silently discarded. Next, we have the LCP operation. LCP function within the data link layer and has a role in establishing, configuring, and testing the data link connections. Next, we have the link maintenance. Link establishment is the first phase of LCP operation, as the phase must complete successfully before any network layer packets can be exchanged. During the link establishment, the LCP opens the connection and negotiates the configuration parameters. The link establishment process starts with the initiating device sending a configure request frame to the responder. The configure request frame includes a variable number of configuration options needed to set up on the link. During link maintenance, LCP can use a message to provide feedback and test the link, as shown in this figure. Next, we have the PPP authentication protocols. The authentication phase of PPP session is optional. If used, the peer is authenticated after LCP establishes the link and chooses the authentication protocol. Authentication takes place before the network layer protocol configuration phase begins. The authentication options requires that the calling side of the link enter authentication information. This helps to ensure that the user has the permission of the network administrator to make the call. Peer routers exchange authentication messages. So now we're moving to branch connections. Remote access connections. Broadband transmission is provided by a range of technologies. Broadband solutions provide teleworkers with high-speed connection options to business location and to the internet. If multiple broadband connections are available to a particular location, a cost-benefit analysis should be performed to determine the best solution. The best solution may be connect to multiple service providers to provide redundancy and reliability. Teleworking is a broad term referring to conducting work by connecting to a workplace from a remote location with the assistance of telecommunications. So here we have the cable system. Accessing the internet through a cable network is a popular option used by teleworkers to access their enterprise network. The cable system uses a coaxial cable that carries radio frequency signals across the network. Coaxial cable is the primary medium used to build cable TV system. The data cable over cable service interface specification is the international standard for adding high bandwidth data to an existing cable system. So we have the cable components. There are two types of equipment that are required to send signal upstream and downstream on a cable system. One is the cable modem termination system, or the CMTS, at the head end of the cable operator. And the second one is the cable modem on the subscriber end. Next, we have the fundamentals of VPNs. So here in the fundamentals of VPNs, as shown in the figure, organization use VPN to create an end-to-end private network connection over third-party networks such as internet. The tunnel eliminates the distance barrier and enables remote users to access central site network resources. A VPN is a private network created via tunneling over a public network, usually the internet. A VPN is a communication environment in which is strictly controlled to permit peer connection within a defined community of interest. A VPN uses virtual connections that are routed through the internet from the private network of an organization to the remote site or employee host. The information from the private network is securely transported over the public network to form a virtual network. The following are benefits of VPN. It is cost saving, scalability, compatibility with broadband technology, and lastly is the security. Now we're going to the types of VPN. We have the site-to-site VPN. A site-to-site VPN is created when both sides of the VPN connections are aware of the VPN configuration in advance. The VPN remains static and internal have no knowledge that a VPN exists. The VPN gateway is responsible for encapsulating and encrypting outbound traffic from a particular site. The VPN gateway then sends it through a VPN tunnel over the internet to a peer VPN gateway at the target site. Upon receipt, the peer VPN gateway strips the header, decrypts the contents, and relays the target host inside its private network. Next, we have the Remote Access VPN. A Remote Access VPN supports the needs of telecommuters, mobile users, and the extranet consumer to business traffic. A Remote Access VPN is created when VPN information is not statically set up, but instead allows for dynamically changing information and can be enabled and disabled. So now we have the DMVPN or the Dynamic Multipoint. So here, Dynamic Multipoint VPN is a Cisco software solution for building multiple VPN in easy, dynamic, and scalable manner. The goal is to simplify the configuration while easy and flexible connecting central office sites with branch sites. This is called hub-to-spoke, which is shown in this figure. This is the hub-to-spoke tunnel. Next, the other DMVPN is the hub-to-spoke and spoke-to-spoke tunnels. This dynamic multi-point VPN with the DMVPN branch sites can also communicate directly with other branch site. This is the hub-to-spoke and spoke-to-spoke tunnels. So now we're moving to access control list. Access control is one of the most important skills a network administrator needs is mastery of the access control list. The access control list provide packet filtering capabilities to control traffic flows, allowing or blocking specified packets on their network. An access control list is a sequential list of permit or deny statements. The last statement of an ACL is always an implicit deny any statement which blocks all traffic. To prevent the implied deny statement at the end of ACL from blocking all traffic, the permit IP any statement can be added. Here we have the rules for applying ACLs. One ACL per protocol, one ACL per direction, and one ACL per interface. When we say one ACL per direction, access control lists control traffic in one direction at a time on an interface. Two separate access control lists must be created to control inbound and outbound traffic. When we say one access control list per interface, access control lists control traffic for an interface, for example, the Gigabit Ethernet 0/0. Next, we have the ACL packet filtering. When we say packet filtering, it controls access to a network by analyzing the incoming and outgoing. We are now going to the types of IPv4 ACLs. So here are the types of IPv4 ACLs. This is the standard and extended IPv4. A standard access control list can be used to permit or deny traffic only from source IPv4 addresses. The destination of the packet and the ports involved are not evaluated. The example in these figures allow all the traffic from the 192.168.30.0/24 network. Because the implied deny any at the end, all traffic except for traffic coming from 192.168.30.0/24 network is blocked with this ACL standard, and ACL are created in global configuration mode. The other types is the extended ACL. In this figure, ACL 103 permits traffic originating from any address on the 192.168.30.024 network to any IPv4 network if the destination host port is 80 HTTP. Extended ACLs are created also in global configuration mode. So here we have the standard IPv4 ACL implementation. We have the configure a standard IPv4 ACL. Here are the following command syntax. In this figure, it provides the detailed explanation of the syntax for standard ACL. ACs can permit or deny an individual host or range of host addresses. And here, we have an example of troubleshooting IPv4 ACLs. As shown in this example, host 192.168.10.10 has no telnet connectivity with 192.168.30.12. When viewing the output of the show access list command, matches are shown for the first deny statement. So the solution, look at the order of the ACES. Host 192.168.10.10 has no connectivity with 192.168.30.12 because of the order of rule 10 in the access list. Because the router process ACL from the top down, statement 10 denies host 192.168.10.10. So statement 20 can never be matched. Statement 10 and 20 should be reversed. So here is my presentation, and thank you and have a good day.